So rational expressions also work with polynomial functions. A fraction where the numerator and or denominator is a polynomial. Here are examples of what a rational expression would look like. And a rational equation is a type of equation where it involves at least one rational expression. That's a fancy name for a fraction. Identity equation are equations that are true no matter what value is plugged in for the variable. If you simplify an identity equation, you'll always get a true statement. And to solve rational equations, we first identify the LCD, or least common denominator. Identify what makes the LCD equal to 0. These are the excluded values. That means those are the values you can't allow x to equal. Multiply every numerator by the least common denominator. Cancel common factors, and then solve for x. And check your answers to make sure that they actually work. So example 1, solve x minus 1 equals x squared minus 4x plus 3 over x plus 2 for x. First, write both sides as a fraction. Left side can be written as x minus 1 over 1. And then identify the least common denominator. Well, between 1 and x plus 2, that's just x plus 2. List the excluded values. Well, we can't let x equal negative 2. That makes the denominator on the right equal to 0. And by right, I mean right side of the equal sign. Multiply both numerators by the least common denominator. So x plus 2 times x minus 1 and x plus 2 times x squared minus 4x plus 3. Cancel those common factors. So on the right side, x plus 2 and x plus 2 cancels. Simplify, so x plus 2 times x minus 1 simplifies to x squared plus x minus 2, and we're just left with x squared minus 4x plus 3 on the right. Start solving for x, so I'm going to subtract x squared from both sides, add 4x to both sides, and add 2 to both sides. That just simplifies down to 5x equals 5, or x equals 1. This is not an excluded value, so if I plug it back into the original, I should get left side equal to right side. On the left side, when I plug it in, I get 0, and then on the right, 1 minus 4 is negative 3 plus 3 is 0. Also, 0 divided by 3 is still 0. So it works. Next one, same thing. Write both sides as a fraction. Already done. Identify the LCD. Well, both denominators are different, so I need one of each. So 4 minus x and 4 plus x is the common denominator. Excluded values, x can't be negative 4 or positive 4. Multiply both numerators by the LCD. So we have 4 minus x times 4 plus x times 4. 5 times 4 minus x times 4 plus x. Cancel those common factors. So 4 minus x and 4 minus x. 4 plus x, 4 plus x. That gets us 16 plus 4x, because 4 times 4 is 16. 4 times x is 4x. On the right side, we get 20 minus 5x. Add 5x to both sides. Subtract 16 from both sides to solve for x, and we get 9x equals 4, or x equals 4 ninths. That's neither of the excluded values. If we plug it in, the left side will equal the right side. And here's some practice for you. Identify all the values of x that make the equation true, so just working through. Practice 2, Kieran had solved it, but he did something wrong. Find out his error and actually fix it. Example 3, identify if the following are identities. So we need to simplify the left side to see if we can get it to equal the right side. So x plus 2 to the third means x plus 2 times x plus 2. So x squared, 2x, 2x, 4, so x squared plus 4x plus 4. Then we need to multiply that by x plus 2. So that gets us x cubed plus 4x squared plus 4x. And then 2x squared plus 8x plus 8. That simplifies to x cubed plus 6x squared plus 12x plus 8. That is not equal to x cubed plus 8. This is not an identity. Part B, do the same thing. So we need to check x squared minus 1 times x to the fourth plus x squared plus 1. Multiply those together and see if we get x to the sixth minus 1. So x squared times x to the fourth is x to the sixth. And then x squared times x squared is x to the fourth, and then we get 1x squared. On the bottom row, we get negative 1x to the fourth minus 1x squared minus 1. The x to the fourths cancel, the x squareds cancel, we get x to the sixth minus 1. They are equal, so it is an identity. And then I'm having you practice the same thing here. Example 4, what are the points of intersection between the graphs of the function f of x equals x squared times x plus 1 and g of x equals x plus 1? First off, set the equations equal to each other. Second, simplify and solve for x. We've got a couple ways we can do this. Can multiply out the left-hand side and then subtract the x and subtract the 1, or we could have left it as x squared times x plus 1 and then just subtracted x plus 1 as one quantity. That actually helps you see the factor by grouping, where you can pull out an x plus 1. And then x squared minus 1, which is left, factors again into x minus 1 times x plus 1. Find the zeros. That would be negative 1 and 1, make any of the factors 0. Plug into the originals and find the points. So plug in negative 1 for g and we get 0. Plug in 1 for g and we get 2. And do the same thing with f. Plug in negative 1, we get 0. Plug in 1, we get 2. So the points of intersection are the points negative 1, 0, and 1, 2. And then I want you to do the same thing on example 4, except I gave you some points to try. And last example, there are many cylinders with a volume of 144 pi cubic inches. The formula for the volume in cubic inches of these cylinders is volume equals pi r squared h. And the equation for the surface area S in square inches is S equals 2 pi r squared plus 2 pi RH. Part A, find H in terms of R. So we know the volume is 144, and that equals pi r squared H. To get H by itself, divide both sides by pi r squared. So there's H in terms of R. Now part B, we want to find the surface area formula in terms of R completely. So that means we need to replace that h with what it equals in terms of r, and that would be 144 over pi r squared. Simplify it, so that'd be 2 pi r times 144 over pi r squared. The pi's will cancel and an r will cancel, and 2 times 144 is 288. So that just simplifies to 2 pi r squared plus 288 over r. And then I want you to practice it with the next one.